So, have you ever been there? You spend weeks, maybe even months, crafting this beautiful suite of automated tests. Everything is green, and then a product manager takes one look and says, wait, that's not how it's supposed to work at all. It's that classic, painful disconnect in software development, right? Our tests technically pass, but they've completely drifted away from what the business actually needs.
But what if? What if your tests were written in a language that both developers and business stakeholders could not only understand, but actually agree on? Well, that's the core promise of behavior-driven development, or BDD. It's the bridge that closes that gap between the business domain and your technical code. So in this Cucumber Java tutorial, we are going to build a production-grade BDD framework from the ground up, giving you an incredibly powerful tool for all your Spring Boot testing.
We are going to walk through every single step, from building a simple Spring Boot application to wiring it up with a really robust Cucumber test suite. And by the end of this, you'll have a crystal clear picture of how to build a powerful, automated integration testing setup that truly reflects your business requirements. Okay, so here's our game plan. First, we'll build our application, a simple Spring Boot web app. Then we'll construct the BDD test suite in a completely separate project, which will act as our automated defense system. And finally, we'll connect them with Gherkin feature files and step definitions to see it all come to life. All right, let's get into it and start by building the fortress. First things first, let's talk about a really important architectural choice. Why are we keeping the application code and the test code in separate repositories? Now, this isn't just a matter of preference. It's a strategic decision that pays off big time when it comes to clean architecture and CI/CD efficiency. So when you separate them, your main application repository stays lean and focused purely on production code. Your test repository gets its own lifecycle, which is perfect for independent CI/CD pipelines, like, say, nightly regression runs. This separation also forces a critical best practice, externalizing your environment configurations, so no more hard-coded URLs in your test code. And it naturally helps you organize your tests into logical layers, which makes the whole system so much more maintainable.
Okay, here's the blueprint for the simple Spring Boot web application we're about to put together. It's a pretty standard Maven project with a controller, a service, a repository, and a user entity. So let's start with the foundation, the pom.xml.
So this pom.xml is really the heart of our project's configuration. We're setting the Java version to 17, and we're pulling in the essential Spring Boot starters. Spring Boot Starter Web gives us everything we need to build REST APIs. Spring Boot Starter Data JPI gives us that powerful persistence layer. And for this demo, we're using H2, which is a lightweight in-memory database, perfect for development. And finally, we're including Lombok to cut down on all that boilerplate code like getters and setters.
Now for the core Java classes. We have our standard demo application entry point, and then there's our user entity, which is just a simple POJO marked with @entity to tell JPA to map it to a database table. But here's where the real magic of Spring Data JPA shines. Check out the user repository. It's just an interface. By extending JPA repository, we get a full set of CRUD, create, read, update, delete, operations right out of the box with absolutely zero implementation code required. It's fantastic.
Moving up the stack, we have our user service, which is where the business logic lives. It's a Spring service that uses our user repository to create and retrieve users. This service is then injected into our user controller, which is marked with @REST controller. This class exposes the two simple HTTP endpoints that we'll be testing, a post mapping at API users to create a user, and a get mapping at API users/ID to retrieve one by their ID.
Now to get this running, we'll use this application-develop properties file. This configures our H2 in-memory database and also enables its web console, which is super handy for debugging. Once the application is up and running, we can interact with it directly using these curl commands. The first one sends a post request with a JSON payload to create a new user named Johnny. The second one sends a GET request to that new user's ID endpoint just to confirm it was created successfully.
Excellent! Our application fortress is built and it's running, so now it's time to build its defenses. In this next part, we're going to construct our automated integration testing framework using the powerful trio of Cucumber, Gherkin, and RestAssured to really put our application's endpoints to the test. So here's the blueprint for our test project, and I want you to notice the clean separation of concerns. We have dedicated packages for our API clients, for config, for step definitions, request payloads, and of course, our test runners. This logical structure is absolutely key for building a test suite that's both scalable and maintainable as your project grows.
Just like our application, our test project has its own pom.xml. And this file pulls in all the crucial dependencies that make this entire Spring Boot Gherkin setup possible. We have the standard Spring Boot starter test, but the key additions here are for Cucumber and for making our HTTP requests. Let's break down the most important ones.
Okay, so Cucumber Java is our core behavior-driven development engine. Then the real magic ingredient is Cucumber-Spring. This is the special glue that lets Cucumber tap into the Spring application context, which enables powerful features like dependency injection in our test code. For our RestAssured API testing, we're using the RestAssured library, which provides this beautiful, fluent DSL for crafting HTTP requests. And finally, Jackson DataBind will handle all the JSON serialization and deserialization for us automatically.
You know, out of the box, Cucumber doesn't know anything about Spring. We actually have to explicitly teach it how to work with Spring. And we do this with these two key configuration classes. The first one, testconfig.java, uses a special Cucumber annotation to bootstrap the Spring context. The second one, demoApplicationTest.java, is a test entry point that uses addComponentScan to make sure Spring can find and manage all of our test-related components as beans.
So that @Cucumber context configuration annotation on our test class, that is the absolute key to this entire process. It basically tells Cucumber, hey, hand over control to the Spring framework. And once it does, Spring boots its full application context, it creates and manages our step definition objects as beans, and it shares that single context across all our test scenarios. This is what enables those powerful annotations like @AutoWired right inside our test code.
Let's be honest, hard-coding URLs is a major anti-pattern in any test suite. So we're going to handle this professionally using the Environment Manager and nResolver classes you see here. The Environment Manager reads environment-specific details like the base URL from a properties file. This lets us switch between environments, like a local developer machine and a CI server, just by passing a system property with zero code changes required.
Now for one of my absolute favorite patterns, the clean client layer. Instead of cluttering up our step definitions with all this messy HTTP logic, we centralize it. The base client uses our environment manager to set up common configs like the base URL and default headers. Then, a specific client like UserClient just extends it, defining simple reusable methods for each endpoint, like createUser and getUser. This is such a critical design choice. It keeps our step definitions focused purely on business logic, not on technical implementation details.
All right, two final pieces of our test infrastructure. First, instead of building raw JSON strings, we use typed Java objects like createUserRequest for our API payloads. This gives us awesome compile time safety and just lets Jackson handle the conversion automatically. Second, since Cucumber steps are stateless by default, we use a ContextStorage bean. It's basically a simple map managed by Spring that lets us share state like a newly created user's ID between the when and then steps of a scenario. Okay, with all our infrastructure in place, it is time for the payoff.
We've built the application, and we've built the entire test framework. Now it's time to connect the two and bring our whole behavior-driven development workflow to life with Gherkin feature files and some step definitions. This right here is our user steps class, the heart of our test logic. Notice how we use @AutoWired to inject our UserClient and ContextStorage beans. And now look at the methods. The userCreate method simply calls our client, gets the response, and stores the new user's ID in the context. Then the AssertUserCreated method retrieves that ID and uses the client again to verify the user exists. The really crucial design principle here is that all the low-level RestAssured logic is hidden away. This class contains only high-level intent and assertions, which makes it incredibly clean and readable.
And here is where it all comes together. This is our Gherkin feature file. It's written in a plain English format that anyone, developers, QAs, product managers, can read and understand. The when and then steps you see here are linked by annotations directly to the methods in our userSteps class. So that line, when I create a user named Johnny, it maps directly to the @when I create a user named string annotation in our Java code. This is the absolute core of behavior-driven development, a living, executable specification of your system's behavior.
So finally, how do we actually execute these tests? Well, we use JUnit runners. And by leveraging Cucumber's tagging feature, we can create different test suites. Just look at the @Cucumber options annotation. The functional runner on the left is configured to run any scenario that has the @functional tag. The smoke runner on the right runs only those tagged with @smoke. This is so powerful because it allows you to run a quick sanity check on every pull request and then a full regression suite in a nightly CI/CD pipeline. It gives you incredible control over your testing strategy.
And there you have it. This architecture gives you everything you need for production-grade test automation. It's a clean, scalable system that, most importantly, produces readable, business-focused tests that ensure your application is always meeting its requirements. For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.